Hello, my dear students. Welcome back to the lecture. So in this lecture, I'll be trying to solve this footing, perimeter and the area, how it has to be found. So directly we are taken from the AutoCAD, right? But I'll teach you the manual calculation also, so that if you don't have AutoCAD drawing in future, you should know how to do it. Like this was a problem, right? So I told you that if I want to find the area of this particular footing, the best option is that select on that, hit on LI and enter. You get both the thing, that is area and perimeter. So now let us say I don't want to do that. I directly want to find it manually. Then how I'm going to do that? So that is what I'm trying to tell you here. So what I've done, okay, I'll copy this footing from here and let me try to do it in front of you. I'll copy the footing, Control C, okay, and I'll come here, I'll paste it here, okay, Control V. Now first I'll try to find the perimeter. Why is that? I want a perimeter. I want perimeter from shuttering point of view, because for the shuttering we know that it is 2 into it's 2 into it's 2 into length plus breadth into the depth, isn't it? Into the depth. So this is my formula for the shuttering quantity for this particular footing. So I want to find the perimeter. If I get the perimeter, I'll get the answer, right? Again, this is actual formula, but here for me length and breadth is not easy, because which one I am going to take as a length and which is breadth. If it is a square footing, only then this formula is valid. If it is a square, or let us say rectangle, in that case let us say this is length and this is breadth, whereas here there is no length and breadth. So I'll try to find the perimeter. How I'm going to find the perimeter? It's very simple. I'll tell you. See, try to calculate all these things. I'll do it in a better way. Let me delete everything once. Yeah, so I deleted everything and now I'll start measuring it. Okay, I'll take the dimension option from here. And now I want to find the perimeter. So perimeter in the sense outside distance I'm supposed to find. So from here to here, I'll measure it. So it is 3800 mm. Similarly, I'll measure here. I'll measure from here. Yeah. Yeah, so it is 6700. Again, I'll measure this one. Again, I'll measure this one. I'll measure this one. Then finally, I want to measure this. Okay. So if I do this, I'm getting everything. Only the thing is, you can see this diagonal part here, and you can see this diagonal part. This I'm not getting. So for that, I'll teach you two options. If you're working on AutoCAD directly, you can see this option, align, and select this part and select this part. Okay. And now it is 2934. Similarly, select this part and this part. It is 2660. But if you don't have AutoCAD drawing, how do you do this manually? So we'll try to do that. For that, what I'll do is I'll try to draw one line from here. And let me go up to here. Okay. Yeah. Up to here. Done. So now I want this, right? I want this I want this diagonal. So if I want this diagonal, I'll simply apply the Pythagoras theorem. For that, I'll measure this distance. I'll ask AutoCAD to give me this and this distance, and also tell me this distance from here to here. So if I get this distance, I can find this diagonal distance. Very simple. Now I know the formula. So Pythagoras theorem, right? If you want, I'll put it even in a more better way. I'll give the naming as A. This is my A. Okay. This point I'll call it as B. And this point I'll call it as C. Right? I want AC now. So according to Pythagoras theorem, this AC will be equal to under root, that is square root, square root of, what is that? AB square plus BC square. Very simple. BC square. Now try to do that. So this AC distance I want. See, by default, AutoCAD has given me 2934. Let me verify that. So square root of, what is AB square? AB is 1575 square, or you can convert that into meter also. I'll convert in meter. 1575. I can write it as 1.575 meter. Okay, I'll write it as the square. Okay, plus BC square. What is BC? Again 2.475. Bracket close. Give this and square. So try to do it manually. If you have a calculator with you, try to do it manually and let me know what is the answer you are getting. I'll do it. So it is square root of 1.575 square plus 2.475 square. So I'm getting 2.933. I'm getting 2.9336 meter on my calculator. And you can see what the AutoCAD has given me. The AutoCAD has given me 2934. It is in meter, almost same. Okay, if you want, let me write. I'll write this in mm. So it comes out to be 2933 mm. Okay. And how much the AutoCAD has given? Almost same thing. It's almost same only. 2934 I'm getting 2933. Right. So this is a method what you're supposed to adopt if you don't have AutoCAD. And this is a method what you're supposed to apply if you're working on a site. Similarly, try to do it for this also. Again, for this also, I'll do it quickly. I'll take line from here. Yeah, done. Take a dimension from here. 2475. Yeah, again, I'll not teach the formula this time. Directly, I'll do that calculation. I'll take square root of 2.475 whole square plus 0.975 whole square. I'm getting 2.660 and I'm getting 2660 here. So it's good. That's it. Finish. Once you're done with this. Okay. Let me take it here. Okay. I'll delete it. Not required, not required. No, yeah. Now directly, if I want to find the perimeter, simply add all the distance here. Okay. That is a peri distance. That is 3.8. I'm starting from here. Concentrate. I'm starting from this point. 3.8 plus next is 2.934 plus next is 6.7. I'm going here. This is the next one. It is 6.7 plus next it is 2.660. I'll come here. This is 2.660 plus this is 3.8 plus this is 3.25 plus next what I'm supposed to do. Yeah, I want to find this distance, right? So this distance I have missed out. Anyhow, I'll calculate it later. Yeah, we'll do that also. I'll take this dimension. I want this distance now. Okay. So 3.25 plus 3.275. Okay. Plus I'll come here. This distance I want 2.750 plus again this distance you can see this distance and this distance is same. Again, I'll take this as 3.275 plus this is how much? 3.250. Okay. Try to do it manually. Let me know what is the answer you are getting. 3.8 plus 2.934 plus 6.7 plus 2.660 plus 3.8 plus 3.25 plus 3.275 plus 2.750 plus 3.275 plus 3.250. So I'm getting 35.69 meter. Okay, and let me verify whether the AutoCAD software is giving the same perimeter or not. So this is a perimeter value. I'm writing it here. I'll write it here. Okay. Yeah. So now I'll ask AutoCAD. I'll select this. Yeah, selected. LI, enter. So you can see the perimeter here. What is the answer you're getting? 35.694. And you can see here, even I also got as 35.694. I got it as 39.694 only on the calculator. Okay, I got it. Yeah. And here also I can see same thing, 35.694 exactly. So this is how you're supposed to do it manually and also with the help of AutoCAD, right? Both the things I've covered. Now perimeter is done. So once you get the perimeter, how do you find the shuttering area? Very simple. I know the depth of this foundation. It's a combined footing what I have. So what is the name of the footing? It is CF1. Come to the drawing. Where is CF1? This is CF1. So the depth is 700 mm. So what I'm supposed to do? Very simple. So perimeter I got 35.694. Multiply this by the depth. The depth is 0.7. So if I do this manually also, no, I'm getting 24.98. What is this? Square meter. Okay. Since it's a shuttering area, 24.97 square meter is a shuttering required for this particular footing. Very simple. Now, next we'll try to find what is the area. Right now, I'll delete everything. See, up to here we have understood about the perimeter. Now I want to find the area. Again, for area, what I can do, I can select it here. I can LI and hit enter. It will directly give me the areas 45.882. But again, I don't want this to do. I don't want this to happen. I'll do it manually. Then how do you do it manually? It's very simple again. So what you can do is, again, I've already done it, but still I'll do it for you again. I'll delete all these things again. Ouch. Yeah, I'll delete all the dimensions. Yeah. Okay. So how do you find the area? So finding an area is difficult because it is neither square, it is no rectangle, nor it is triangle in shape. So the best option what you can do is try to break this into such a shape so that you are going to find it very easier. So one way what you can break is, see, you can put a line here in this way, and this is one way you can do. Okay. Then you can break it here. Then you can break it this part into a triangle. Right. Then again, you can break this part into triangle. This part into triangle. And you can find the area. But again, what will happen? See, this is not exactly triangle, isn't it? It is something like this. Again, you have to break this part now. Again, I'll break this part. Now it is fine. Now this is fine. Again, I'll break this into triangle. You're getting my point? Now what has happened? I have broken down this into triangle, this into triangle. Then this is a rectangle, one square here, another square here, and small two rectangle here. This is one way of doing. The second way, instead of doing this way, I've done it here. This is even more easier, right? Here what I've done, I'll teach you that also. I'll copy the same thing. Control C, Control V. So instead of breaking it in this way, like a rectangle, triangle and all, we can make it a bit easier. In the beginning itself, try to break it into one triangle. I'll break this into triangle now from here. I'll bring it here. And I'll bring it here. Okay, this is one triangle. Similarly, here I'll bring another triangle. Yeah, so two triangles are done. Now what I'll do, I'll break this here. In this way I can break it. It's one and the same thing. There's no much difference here. Okay, and now I'll break this in this way. I'll cut it here. I'll make this as one part. And I'll make this as another part. Now it has been broken into different. Again, like there's one square here. This is second square. This has become into a rectangle. one triangle, another triangle, and a small rectangle in this part, right? Now you can do the calculation, right? How you are going to do it? Very simple. I'll take a dimension now. I'll try to directly measure all these things. From here to here, it is 3800. Similarly, from here to here, it is 3250. Again, from here to here, it is 3800. And from here to here, it is 3250. It's the same thing, okay? Then what I want, again, I want this distance from here to here. Wait. Yeah. I want this distance. And then I want this distance. Done. Okay. This anyhow it remains same, but still I'll take it. 2475. Got it? Then which distance I require? Yeah, this small distance I require. From here to here, 525. And this distance I require. Yeah. Now just calculate it. Just calculate the area now. First I'll calculate the area for this square. Then I'll calculate it for this square. Then I'll calculate for this rectangle. Then I'll calculate for this rectangle. Then for this triangle, small triangle, and for this small triangle. So another 2 dimensions I require. Say I want this dimension also. Okay. Yeah. And then I want this dimension. These dimensions I need. Good. So everything is done. So quickly I'll do that now. So whatever answer I get, I'll write it here. First I'll do for this, for the square. Okay. For the square portion, it is 3.25 into 3.8. So 3.25 into 3.8. It is 12.35 square meter. Okay. So another square we have square 2. I'll give this as square 1. I'll give this as square 2. So right now I'm doing for this. Okay. Again, here also it is 3250 and 3800. You can either multiply the first answer with 2 or you can do it again. Again, it is 3.8. What is the answer? 12.35. Yeah. Next, I'll take this particular rectangle portion. Okay. So I'll take this as rectangle 1. Rectangle 1. So what is the dimension I have? So this is 6675. 6.675 into what is the breadth of this? So the breadth is 2.475. 6.675 into 2.475. 16.520 I'm getting. I'll write it as 52. Then what is left out? Then this small rectangle I'll take. So this is 525 and this is 2750. I'll write it as rectangle, small rectangle. Okay. And this one I'll make it as rectangle big. Okay. So it is easy for us to understand. Rectangle big or big rectangle. Okay. Yeah. So it is 2.75 and multiply this by 0.525. 2.75. So 2.75 into 0.525. So this is 1.44 square meter. And finally, we have a triangle. So I'll write it as triangle 1. Triangle 1. So first I'll take this triangle. This is a triangle. Okay. So this is triangle 1. So how do you find the area of triangle? It is half into breadth into height, right? Half into breadth into height. So half it is 0.5. What is the breadth here? So the breadth it is 2475. So it is 2.475 into what is the height? So this is my height now. Okay. It is 1.575. 1.575 equal to 0.5 into 2.475 into 1.575. So it is 1.94 square meter. And next I'll go with the triangle 2. Yeah. So where is the triangle 2? This is my triangle 2. So again, formula is half into what is the length? Length it is 2475, 2.475. And what is the height of this? So take it as 975, 0.975. Do the calculation. 0.5 into 2.475 into 0.975. So I'm getting 1.20. Yeah, that's it. Simple. Now try to add everything. You'll get the total area. Therefore, total area will be, try to add everything. Okay. So I'll do it manually. Add everything. 12.35 plus 12.35 plus 16.52, 1.44, 1.94, 1.20. So 12.35 into 2 plus 16.52 plus 1.44 plus 1.94 plus 1.20. I'm getting 45.8 square meter. And let me verify whether whatever I have done is correct or not. Hopefully it will be correct. If it is wrong, we'll try to see what is the reason behind that. I'll say li, enter. So you can see it here. 45.882 is what we are getting. And manually also I have got 45.8. Okay, that 882, because if I take 3 decimal, it will come out to be 45.882. Got it? So both the thing I've taught you how to do it manually and also with the help of AutoCAD. If you want to do it on the AutoCAD, directly click here and you can do that. Otherwise, this simple approach you have to apply. Break the entire, or what you call this? Yeah, break this particular shape into such a shape so that it is easy for your calculation. You can break this into a square or a rectangle or a triangle and you can do the calculation. Very simple, right? Yeah. So I hope up to here your concepts are clear. Try to make use of this calculation in the earlier Excel sheet, whatever I have given, and you can try to complete this. So we'll see you back in the next lecture.